Okay, ladies and gentlemen, uh, 2A requested to see solving similar triangles in context problems 1 and 2. That was on the big board. So let's do it. So here's the thing about this before we start. You can't freak out. Like if you're gonna sit here and freak out about like word problems, a lot of reading, my advice would be to grow up. Like that's just how it is. Like you're gonna have to do a little reading, do a little kind of analyzing to understand the problem. But in the end, you can do it. These problems are fair, albeit tough. And what you really have to consider is where the triangle is. Like if you have not picked up on this, the key to all these problems is simply finding where in the world the triangles are, proving they're similar, and then going from there. So I'm not going to read this out, but here's Hank, and he wants to find the height of this building. So he uses sight line to do that, not shadow, just sight line. So he positions himself perfectly, and not being Phil Speederman, he has to do a little measuring along the ground instead of the building. But so I was kind enough to draw this picture for you, but let's take immediate note that my goal is to find this value, which I'm going to call x. So I'm going to search for the triangles. Like if this looks like triangles, but it's a little bit tricky maybe to find the one you actually want. So the thing to consider on this one is that the triangle, his sight line, I'm sorry, starts as I. The triangle should start at the I too, meaning the triangles I'm looking for have nothing to do with his feet, but have everything to do with his eye line because that's where the vision line emanates. So the triangles in question are two. The red one I just have outlined, and of course this little guy here. Now, before you say I don't have the values for that, you actually do. You just have to do a little subtraction. Now, of course, the values along the bottom are going to carry exactly, but it tells you that Hank is a certain height, whereas 1.72. So this distance here, let's see a different color. This distance here is 1.72 meters, meaning that this distance, which you actually need to solve, has to be a difference between 3.25 and 1.72. And me being not the hero, let's see, 3.25 subtract 1.72 makes this distance 1.53. And that's all I really need because I have the lateral distances left over from the ground. Of course, those distances are going to change just because they've been elevated by 1.72 meters. Um, but that's why I had to solve for x. Now we have to be careful because this is not going to actually solve for x. It's actually going to solve for this height, which is y. But as you can see, I can do a quick addition problem of 1.72, which is Hank's height, to get my full value of x. But again, it's always going back to finding triangles, right? So it's all about setting up the right ratio. So if I take this 416, which is the length along the bottom, and compare it to, say, like the entire length from side to side, and again, let's not make the mistake of making it 114.3. I want the entire length, which means I add that to 416 and get 118.46. So it's the entire length of the small, the entire length of the big. And the reason why I have to use the entire length in this case is because I am using the entire sides of these two triangles, 1.53 and y. Okay, so let's solve the other side. So entire side of the small triangle, 1.53, and then the entire side of y. So that's really it. Like once you kind of get the setup of it, once you realize the triangles have to be elevated off the ground because that's where the sight light starts, and then you have to do a little subtraction problem here to get 1.53. Finding y is actually a pretty easy proportion. Not one in terms of like nice numbers, but one that when we cross multiply, and then divide by 4.16 to solve for y, we have this partial distance, 43.57, that will be here. So this is 43.57. That does answer our question, and you always want to take note that I asked you how tall the building is. The building height is actually x, which means I have to add this value uh, back to Hank's eye height. So x is actually going to be equal to 1.72 plus y, which if I add 1.72, I get 45.29. And I didn't put label there, but of course that'd be meters. All right, so again, it's all in the picture. Like you have to understand you're looking at similarity. You have to be able to identify the picture. And that's going to be no different here with Mr. Flag, okay? So again, I'm not going to read that to you. So by all means, please pause the video, read it if you haven't yet. But again, what I'm going to focus on is the fact that we're looking for triangles that happen to be similar. And this one again uses like this idea of like eye line. So um, in the problem, this person is looking at the top and the bottom of the pole using this right-angled squaring board. And it's right angled because it's a square. And this is a real thing. This is actually how they did it. So if I draw on the eye line from here to the top of the flag pole, and then here to the bottom of the flagpole, and again, please excuse my less than perfect drawing, and I don't think that's quite a right angle, but this is a representation. We have ourselves a big right triangle. Now, this might be a mystery of what to do next until you kind of examine this measurement and you kind of take the principles of Hank's problem and apply it. This measurement 2 should not only apply on the ground, but should also apply right here. In the same way, measurement 1 should not just apply to the height, but should apply here to the flagpole. If I'm looking straight at the flagpole, that's got to be a right angle too. Whoa, wait a minute. I have right angles and right triangles. That looks a whole lot like this kind of problem. And as it turns out, it should be the same exact problem. We're going to actually have count them, three proportional right triangles to solve. Before we get any farther, let's put some measurement. Let's see, how tall are you? You're 5.5 feet. And you're 12.7 feet from the flagpole. So again, we do have three triangles here. If you didn't see the first video, that last problem number 5, go back and check that out first, because if you don't understand that problem, you don't have a chance of understanding what's about to happen here. But I'm going to use a similar technique, and that technique is going to be redrawing these triangles. But before I do, let's do some labeling of what I'm trying to find. The only thing I'm interested in is this height. And let's go ahead and take note that I already have most of it. So really, all I have to find is just this chunk up here, which I'm going to call x. If I can find x, I'm done. Like I am absolutely 100% done. And it turns out I do have enough here to find x. The reason why is because I know that's a right angle, so I don't even need the big triangle here. I can actually reduce it just down to 2 small triangles. Let me explain what I mean. So I have this triangle on the bottom, which I'm going to rotate so it's kind of in its upright position, meaning that 5.5 is here and 12.7 is here. If I take a look at the medium triangle, I'm going to kind of draw it in its upright position. Okay. I do have to do a little switcheroo. Oh, excuse me, I don't have to do a little switcheroo. Let's see. So that would be 12.7 here, and then of course I'm trying to find x. Okay. Sorry about that, guys. I was thinking about angles. But anyway, we do have two similar triangles here. And of course, if you're kind of wondering about the similarity in this particular case, I invite you to think about angles really carefully. I don't know what this angle is. I was never told. But I do know that angle has to exist. And because that angle exists, this guy right here has to be 90, subtract that angle. So like in other words, if x is like 50, that has to be 40. Right? In the same sense, if I think about the big triangle, this guy up here has to be 90 minus x, okay? Meaning that this has to be x. Okay? So that's how I'm kind of getting my alignment. That's what I was thinking about in my head. So in other words, if like x is 40, 90 minus x has to be 50. And if x is 40, think about the big triangle. The top one has to be 50, meaning the one on the corner has to be x, which is how I'm kind of getting my alignment. But once you get to this phase, like we're almost done. Now we just have to set proportion and solve it. So like 5.5 is to 12.7. Let's keep it within the same triangle. It has to be the same as 12.7 is to x. Now let's just solve. Where's my calculator? So 12.7 times 12.7 equals 161.29. And that's going to be the same as 5.5x. Divide that thing by 5.5. x is equal to 29.33. That's not my answer. That only takes me this far, but if I add 5.5 to it, so in other words, the height I'm looking for is equal to x plus 5.5, which is the height of the dude. Let's see what we got here. It's going to be 34.83. So 34.83 on the flagpole. All right. So those are the two that were asked for by A group. So I'm going to go ahead and stop there. Again, if I can teach you a lesson on this one, it's got to be you got to draw the picture. You got to make sure it's lined up right. You got to make your proportions right. Even if you have to stop awkwardly in the middle to do it, you got to be able to make sure your proportions are correct. All right. So if you want further explanation, please let me know. But someone asked to see those worked out in video, and so there you have it. I'm going to post this right now. Thanks.